Abstract. Today, our goal is to kind of give you an overview of what abstract is, and also deep dive some of the code that we have, and the SDKs and the way that you can develop your applications with abstract. So maybe first a little bit of background on our team. So my name is Robin. I co-founded Abstract with Adair. I met Adair at the first Cosmoverse conference in Lisbon. Abstract wasn't a thing then, and we just became friends, and later on founded Abstract. And while I met Adair, I was working for White Whale. And what I really experienced as a developer writing smart contracts was that it was just really hard to do, and it was really inefficient. So I don't know how many of you have ever been like decoding and encoding base64 strings. You can maybe show an emoji or something, but I remember that just being awful, and like making JSON messages and stuff. So that really brought us to kind of the idea of making the developer experience as a whole way better. And as we were building this, we realized that it's not just a developer experience. There's like more problems in this space. And we identified three that we really want to tackle with Abstract. And the first one is that the apps are being built from scratch. And plain and simple, it's not very efficient to be building our applications from scratch. And it makes it very costly and time-consuming to ship products and to iterate on them. Second of all, there are no real incentives for developer teams to collaborate. Which means that, yes, like it's very decentralized, but we're not really coming together as a group of developers to create the best and dopest applications out there. And that's really a shame, because the Cosmos has some really great developers. As a third point, the thing I mentioned before, the developer tooling is just not really there. And that's also something that we're trying to tackle. So as a brief overview, what I'm going to cover here today, what is Abstract? I'm going to talk about account abstraction, because that's a key part of Abstract technology. I'm going to talk about Abstract modules, which are smart contracts that extend the functionality of our platform. And then I'm going to talk about the SDK, which is how you as a developer can start programming and making use of this technology. So what is Abstract? Abstract is an account abstraction-based smart contract development suite. It features user-owned smart contracts. We have an on-chain smart contract version management system. We have an intuitive and composable SDK, and we also have a smart contract marketplace. So I know that's a lot, so let's start unpacking that. The first key concept that I need to explain for you to get the concept of abstracts as a product is account abstraction. And it's been making a lot of headlines in the Ethereum ecosystem. And if I were to explain account abstraction, I would say that it is the concept of enabling an application to perform action on a user's funds without that user surrendering ownership of those funds. And that is in stark contrast with the kind of applications that are out there right now. So, for example, if you want to use an exchange or lending market, or really any smart contract currently out there, you move your funds over to that smart contract, and you trust the developer of the application to be responsible with your funds. With account abstraction, we kind of turn that around, where we create a smart wallet for the owner of the funds, and then we give the application permissions to interact with that smart wallet. And this is kind of a change in the way that you need to think about applications. So if you want to start working with account abstraction, you need like 3 technical requirements. First of all, you need some kind of smart contract wallet. Then you need the ability to set permissions for that wallet. And then if you want to write applications with it, you want there to be some kind of programmability of that wallet. And the programmability is really where we try to make a difference with Abstract. We want to make it super, super easy to start programming the different functionalities that is smart, that you could do on chain with someone's funds, right? And how do we do that? How do we implement account abstraction in Abstract? Well, we we create these abstract accounts, and they consist of 2 smart contracts. We have the manager smart contract and the proxy smart contract. And the proxy smart contract is really the smart contract that holds the funds of the account, and it verifies and executes transactions that get sent to the account. And it can also perform some value calculation logic, which allows the developer of a smart contract to ask the proxy contract, hey, what is the value of the assets that are currently at your address, that are currently held within this smart contract wallet? And that's really useful. The second smart contract is the manager smart contract, and it administers the account. So it handles, it is the admin of the account. It can change configurations. It handles version management of the different contracts that could be interacting with your account. It has a technical ownership of the smart contracts for things like migrations. This is really important. And it is the admin of this manager contract that is the owner of the account. And that could be either a person's wallet or a DAO, right? With DAO, the DAO could be the owner of this account. And to create these accounts, we have a smart contract factory, which is pretty standard. And it creates one account and it assigns a unique ID to the account. So at this point, I would like to ask if there are any questions regarding the concept of account abstraction and how we kind of handle that within Abstract.
How about you quickly go through a few examples of why this will be useful, right? We've been seeing a lot about account abstraction lately, and we know that most chains are moving towards this. Ethereum's pretty far behind it, but maybe walk through a core example of why Cosmos could really use this.
So honestly, the way that we approach the account abstraction is different from the way that Ethereum is approaching it. I think the way that we approached it is kind of a consequence of asking the question how we can start reusing code that people write and smart contracts that people write, and how we can start composing these smart contracts in a modular way to create more novel functionality. And as a result of that process of thinking through that problem, we kind of came up with the fact that we need some system that turns out to be account abstraction. But we hadn't really heard about that term when we started Abstract. So it's kind of funny that that's account abstraction, right?
It's a fancy word. It's a fancy word, right? Because if you look at some chains, like Solana out of the box has account abstraction, but it's not called that. And so really Ethereum's low-level wallet structure is what really triggered that term. It was really, payments is really what pushed that term, in my opinion, because Visa came to the forefront saying they can't use Ethereum because it doesn't have account abstraction, right? So payments will be a big area in which it'll probably be used.
Cool. Guess I'll continue. So next on, I like to talk about the abstract modules. So abstract modules are installable smart contracts with account execution permissions. So these are individual smart contracts that have the permission to execute commands on the smart contract wallet. In the future, this could be kind of a role-based approach where you specify what kind of messages can be executed by the smart contract. But for now, it's just a general permission to execute execute messages. And you can compose these modules to create decentralized applications. You can monetize them individually on a per smart contract level. And there are security benefits to the fact that you kind of create a modular component, because there is a separation of concerns. Every single module is responsible for a very specific functionality, and it's just easier to test and verify. So in order to build these modules, we came up with the idea of a module scaffold, and it is a package that offers fundamental account abstraction functionality that can be used to further develop your application on top of. So we're going to talk about this more when I go into the code. But for now, just know that we have two kinds of scaffolds. We have the app scaffold and the API scaffold, and I'm going to quickly go over them. So the app scaffold is it's like a type of module, and it is instantiated when someone installs it. It has the manager as its admin. It is a contract that can be migrated, so new versions of this app can be uploaded and then migrated to at the control of the user. And it has execution permissions on the proxy contract. So as an example, to make it very practical, let's say that I want to create an ETF application. I want other people, or my friends, or my family, or whatever, to be able to invest into an account that I control, where I can trade assets that are held within this basket of assets. And I want them to receive shares of this basket, and then later they can claim their tokens by redeeming their shares. So little flow diagram: when someone wants to invest in this ETF, they deposit their tokens into this ETF module, the smart contract. The smart contract will then ask the account for the value of all the assets that are currently in the basket, and that way it can figure out what the share of the deposit is worth, basically. So how many shares it needs to issue to the depositor, and then it will forward those deposits to the account and mint the shares to the user. And then when the user wants to withdraw, he can send his shares over to the ETF. The ETF module can then again ask for the value of the vault and calculate all the asset balances that need to be sent back to the depositor and burn the received shares. So that was the app scaffold. Now there is also the API scaffold. And the idea of the API scaffold is that it's a wrapper around on-chain services that does not have an admin, and it cannot be migrated. So it's kind of a generic endpoint that people can use in their smart contract to use some kind of functionality, like a DEX or staking their assets, which is, you want the functionality of swapping your assets. You don't necessarily need to want the complexity of having to integrate with a specific DEX to get that functionality. So as an example, we have this DEX API standard interface for interacting with exchanges. And this can be very useful as a dependency because it allows you to perform a swap in your smart contract with one line of code, which is very powerful. Again, a small example: if a user wants to swap some of its funds that he has in his smart contract wallet, he can send a message to this API contract, and this API contract will then identify the exchange that the user is trying to swap on, and it will construct a message specific to that exchange, or messages specific to that exchange, to perform that swap, and then forward that to the smart contract wallet, which will execute it and actually perform the swap with the user's funds. And small note here is that the manager can only call APIs on its associated proxy, so there is no way for me to call actions on the account of someone else, basically. And then once you start thinking about these smart contracts as modules, you can start composing them to create more novel applications, like, for example, an auto-compounder, right? So how does an auto-compounder work? You deposit into the auto-compounder, and it uses those assets to provide liquidity to a pool, and then stake those LP tokens with the incentive staking contract. So if we separate out the kind of functionality that we need, we have a DEX API that interacts with DEXs, and we have a staking API that provides the staking logic and unbonding logic that is required when you stake somewhere. And so this auto-compounder can take on these dependencies on these two contracts, and then can then very easily interact and perform the staking and swapping and providing liquidity without needing to integrate with any exchanges or DEXs itself, right? And you can think of more use cases for these modules, but the big idea is that everyone can start reusing the smart contract and doesn't have to rewrite all that code. And another kind of benefit of this is that if we have, let's say Jane is writing an application and she wrote this module that she thinks is really useful, she can put it up onto our module marketplace. And then some other team can see that and can say, wow, great, we don't have to rewrite all this logic again. Someone else already wrote it. So we're just going to install it and use it as a dependency in our own application. And then Jane can actually be paid for that, because she's really providing value to these developers. So this is the point where I'm gonna start diving into the code. Maybe again, are there any questions? Nope.
I think maybe just highlight on a high level, you went through it, but just think of, I don't think many people understand the importance of putting these into modules, right? The number of, even from a user perspective, think of how this simplifies the user experience, right? Maybe explain that a little bit from a user side of things, why this is important, right? Just maybe walk through the auto-compounder example, and with abstract and without abstract from a user perspective. Maybe that can paint a pretty clear picture.
Yeah, sure. So one of the things that I didn't mention really, but yeah, one of the things that is also a piece of this is something that we call like the abstract name service. And it's a way for us to identify certain assets or contracts with a human, with a human readable name. So no Terra 1 XZ blah 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 address. And by separating that that kind of complexity into something human readable, we can provide the user with a message that is extremely readable, right? They get this message to perform a swap on a DEX, and they can see, okay, the DEX is Astroport, the asset that I'm trying to swap is Juno, and I'm trying to swap this for the raw token. And the even better is that if you go to a different chain, we have the same system there, right? it's still in the same format. The names are still the same, but the underlying addresses of the assets that are used on chain are different, because these are IBC assets, maybe, or CLB20s. So depending on which chain you are, a certain token might have will have a different denomination underlying it. But as a user, you don't get any information from seeing an IBC denomination. It's worthless to you. So it's really nice for the user to see that human readable message that they're then signing in their wallet. And maybe another spin that I could give to this question is that with this module marketplace, it becomes really easy to distribute software, which means that in the future, we could be looking at an on-chain smart contracts infrastructure that is actually owned by every user individually, where they have full control over their funds, and also the smart contracts that interact with their funds, because no one else can migrate these contracts for them. They have to specifically say, right now I want a new version of this contract, and that mitigates a lot of I guess like legal issues that could possibly come up in the future, where developers are kind of becoming liable for their contracts, but they still want to have the upgradability of that and have that flexibility in keeping their contracts up to date.
And not only that, but from a developer perspective, they can have they can actually create a sustainable income path for themselves by listing these modules on the marketplace and having other applications that are composed of these modules, paying for these and paying for the developer salaries in the Web3 world. And it also allows for some sort of a reputation to be given to each of these developers. And of course, people would rather go with a reputable developer than one that's just like some random fork of Uniswap per se. And with that, there is the number of lines, average number of lines when modularizing smart contracts. It literally reduces it to like around 75%, or reduces it by 75% of the lines for smart contracts. And the interactions between your smart contracts, your little modules, because they're like on-chain microservices, you can really isolate the logic to these modules, which means that you can have specific teams and specific subsets of your teams dedicated to maintaining the specific logic that they are skilled in. And so it allows for modularizing not only the smart contracts and your architecture, but your teams as well, which minimizes the attack surface of your applications, and which is why we built them as modules.
Cool, awesome. Okay, at this point, I will dive into some of the code. So remember that I was talking about this app scaffold.
Bigger, please.
What?
Bigger? Can you make it bigger? Yeah.
Good. Cool. So this is the app scaffold. We are open source, by the way. You can find us on GitHub. Abstract2s, maybe out there, I can put a link in the chat. But this is the base implementation of the module. So one of the two types that you could choose. And we have the state, some initial state with a proxy address and an abstract name service host. But just know that our scaffold already has some state and already manages some state without you as a developer needing to know about this, really. We have the struct, and there are a bunch of generics, which I will talk about later. We have the admin of the app, which will be the manager contract after instantiating it. We have the base state, which I just showed. And then we have this abstract contract that has a bunch of generics. So if we go into this abstract contract, we basically get like a very generic way of describing what a CosmWasm smart contract really is. First, we have some identification for the module. We have the version, we have some optional metadata. We also store the version on chain. So anything that uses this abstract contract as like the core struct will already have the version information stored on chain. We can set some dependencies, and then we have a bunch of handlers with generic messages that can optionally be set. And we will see how to use that later on. But for now, just know that these messages that are generics for this contract are really what identify your smart contract for other contracts to use. So if you think about a smart contract, really the most important thing about a smart contract is what kind of messages it accepts. And if you think about creating a generic smart contract that can be built up layer by layer, you kind of need to start with a very generic message and then fill in the different generics wherever it makes sense. And that is what we did. So we have a execute message, instantiate message, etc. And these are the generic outlines of the kind of message that a module expects to receive. And it has generics that can be filled in by the developer of the module. And in this case, we, in the case of the execute message, we have a base variant, a module variant, an IBC callback. So we also have support for IBC, which is not generic. And we have a receive endpoint, which can be used for CW20s or external services, like the noise network. And then with this message, we can define our endpoint for the app contract. So we have this scaffolding contract, this app contract, with a bunch of custom generics that still have yet to be defined. But at this point, we already know that it's an app contract, and we know that it has some state that we want to manage. So what we can do is we can define the endpoint of our contract, the entry point for the execute message to be of the format that's shown here, where we already filled in the base execute message as the base variant of the execute message. Okay, so we know that it receives this kind of message, but with the base variant being the base execute message of the app. And then in our implementation of this trait, we can map, we can match with the different variants of this execute message, and then execute the logic if it's a base execute message that fits with this app contract. And for the API, this will be different, right? And so right now we have an app, we have an API, but in the future, like really all bets are off. Like you could have all kinds of different base layer implementations that can be used for different use cases, like ETFs or whatever. Cool. So now that we have that out of the way, we can look at how this can actually be used, right? Which is kind of more important. So I talked about this ETF application while we actually already built it, and I'm showing it you right here. And this is a contract.rs. And first of all, I hope that you notice that it's really nice overview of what this contract is and what kind of functions it supports. But more importantly, we set this ETF app type, the type alias, to be our app contract with the different generics of it specified. So we have an instantiate message, an execute message, query message, and a CW20 receive message. And by doing this, we give Rust the information that it needs to properly define the message that it expects at the entry points of the contract. So in our message.rs, we can actually set another type alias to be our ETF app as the trait that I just showed you, with the associated type of execute message, because this is now a fully typed type, so it knows what the execute message is. And then once we have this type, we can create an instance of it with a const builder. So this is also kind of a really important aspect of it, is that what you're doing right now doesn't really incur any runtime overhead. So all this stuff is done at compile time, which just is really nice to know that you're not really taking on any garbage. And then with this builder pattern, you can set the instantiate handler, the execute handler, the query handler, receive handler, replies. And then for the replies, you can say, hey, with this reply ID, I want to match it with this reply handler, etc. And then normally you would have, in a normal contract, you would have some attributes that export like a C pointer, basically, to indicate the entry point of a contract. Well, because of the way that we constructed everything, we can have a nice macro that just does all that for us to kind of remove the boilerplate that we would otherwise need. And then in this execute handler, for example, you can probably recognize most of the attributes of this, except for the app. So this app object that we created right here, the const, is also available in our in our execute handlers, in our essentially like in all our handlers. And that's really nice, because that is what will be used by our SDK to provide you with a lot of the functionality that is so valuable to us. So at this point, I kind of want to jump back to the slides and talk a bit about our abstract SDK and how you can use it to really supercharge your development in CosmWasm. So the abstract SDK, you can think of it as your account abstraction toolbox. So we have helpers for doing asset transfers, for verifying if a sender is an abstract account, to do IBC transactions, to access our abstract name service, and to do account execution. We also have documentation for it available, which we tried our best to kind of give you a good overview of how to start working with it. But I think it's useful to go over what this kind of looks like and how we designed it and how we made it very flexible for you to exploit and really build upon. So one of the features that it has is doing transfers with your account, right? So the basic structure that we put in place in our abstract SDK is the idea of creating an object for each specific functionality and then providing methods on that object to perform actions on your account or to retrieve information, etc. So in this case, we have a super trait. It's called transfer interface, and it has a function bank that returns a bank object. And then in order to transfer assets in your smart contract, you call the transfer method on the bank object with a vector of funds. And these funds can be coins, or they can be CW asset structs from Mary's library. And you provide a recipient, and it will return the Cosmos message that you can then add to your response. And this will transfer the funds from the smart contract wallet to the recipient. And as you notice, it has two trade bounds. So we have the abstract name service as a bound and the execution. So let's go one level deeper to the execution interface. And this is, again, the same kind of principle. You can create an executor on any app object or API object that implements these two traits. And then you can execute messages on the abstract account with the execute call, and you can provide it a vector of Cosmos messages that will return a Cosmos message that you can add to your response. Right, so I hope that you kind of get the hierarchical structure, and the fact that these traits really give you a lot of freedom in implementing some very simple traits on these base objects, or the scaffolds that I call them, and then start to create more complex functionality on top of them that can be reused by everyone who's using the same scaffold, which is, again, just really nice. And the basic features that don't have any that aren't super traits are what we call features. So they are also traits, and they are traits that retrieve some module information. And the idea is that, again, if you have a smart contract that has similar state to another smart contract, then why not create traits to retrieve that information and then build on top of those traits, so that every smart contract that has this data available can use these traits to perform the same actions. And this is one of the examples. So this pub trait account identification is a trait that is also implemented by our app. So if we go into the features, we have our account identification, and this gets the base state, loads it, and returns the proxy address of the base state. And given this trait and the other trait, we unlock the ability to transfer assets in and out of the abstract account. Cool. So before we jump into the front-end demo, I'd like to ask if there are questions about this part. I hope it wasn't too much to take in. So tomorrow, our goal is to kind of get anyone that's in the call hands-on with what we've built, and to help them play with it, and to create some kind of application with it. Sure.
Yeah, question.
Yeah.
Hey guys.
Hey.
Yeah, I want to say that it's awesome. Like me myself, probably was thinking that I need something like that. Just didn't have the power to build it on my own. So yeah, it's great idea. Looks awesome. And just have like basic question. When is the production ready?
Good question. So since there are a lot of moving pieces to this, we have decided to get the core smart contracts audited. So this is the manager contract and the proxy contract. And this is really where all of the security aspects are really important, as well as the templates, the scaffolds, so the API and the base packages that I was showing you in the code. Those are currently being audited, and I think we are getting We are getting the first report of that today. So we're really trying to get this out there as soon as possible. We have a first customer as well, 42 Finance, who built the auto compounder actually that I was talking about, and they're also getting their smart contracts audited. So we're really hoping to push this out, as soon as possible.
Nice.
Another guy's over at 42.
Congrats.
Cool, thanks. Any other questions? Adair, are you ready to take over?
Sure. Hi, everyone. We didn't do introductions earlier, but I'm Adair, co-founder of Abstract. As Howard mentioned, we met at CosmWasm 2021. Turns out there were Terra maximalists at the point, and we had built a similar project with the Mirror and Anchor protocol, which is kind of funny with the delta neutral strategy. My background is actually in music, so a big part of my life is collaborating with other musicians, and I applied the same thing to coding. Coding was actually my hobby, but it kind of transformed into my day-to-day these days. I did a double in CS and music in college, and one of the core reasons that we're building Abstract is to allow developers to have the sustainable income. I mentioned this earlier, but in the Web2 space, it's not really possible for one to monetize their contributions, to be able to be rewarded for something that they, as a developer, as an artist, have built and shared with other individuals and have brought value to the world. And so I really want to see this value capture being brought back to the creators and to the contributors instead of like the big corporations. And so that's kind of why I work in Web3. And so with that being said, I'm going to show you some of our developer front end. I will let you know that there's two versions of this right now. The first, which I'm going to show you because it has the appropriate nomenclature, is at wba.abstract.money. And I'll paste this link in chat as well. And we recently just did a renaming refactor, and there's a lot of changes. So I will be starting out with this WBA front end with the appropriate names, and then I may migrate to the old front end to show you some of the more of the functionality that Abstract has that is not yet deployed in the new version. So I guess once you enter this account manager, so this front end, again, it's for developers, and it's kind of like an account manager. Developers who want to build applications by composing modules, they can come here and they can do it visually. We definitely recommend doing it all through code, but this allows for easy management of your accounts and your applications.
Can you zoom in a
So
bit?
yeah. All right, how's that?
Yeah, that's better.
All right, thanks. So I guess the first thing I'll go through, Howard went through this in his presentation, but there is each Abstract account has an owner, and this owner, of course, can be any smart contract, any EOA. It could be like a multi-sig, it could be a Vectis wallet, so on and so forth. And like the default ones that we just have available on our front end are like creating a monarchy, which is where you are the single admin and the single owner of it. And someone is echoing in the background, by the way. And there's also a multi-sig where you can actually create your multi-sig. With this UI, you can set up some additional members. I actually think this one's a little bit more fun, so I'll go over this one. And then of course we have the DAO integration. And here's some alpha. This DAO integration is not going to be exposed through the abstract front end, but rather the DAO front end. Wouldn't it be awesome if your DAO could manage an account or many accounts, or manage an account that managed many accounts? It's coming soon. So let's go ahead and create a multi-sig. We can call it WBA multi-sig. This is a description. Whatever. This is here. And this link, it really doesn't do much other than provide the favicon for your account, as well as provide some sort of external reference, external metadata for your account should anyone choose to ask for that metadata on the account. So we'll set up myself as the only member of this account, unless someone else wants to join in and participate in this multi-sig. Might be easier just to do this though. So I'll go ahead and right now I'm creating a CW4 group with myself. And after the CW4 group is created, I'll go ahead and create the multi-sig. And once this multi-sig is created, I'm going to instantiate an account, an abstract account, which is composed of the manager and proxy contracts with the multi-sig address as the admin. And so, as you can see here in this message, it says create account. Can you see me zooming in, by the way?
Yes.
Okay, cool. So we create an account, the description, the governance type, which is a monarch, with the multi-sig address as the monarchy, and then the link and the name, of course. So go ahead and approve that. And once that's approved, it'll take us to the actual management front end for this. So on this front page, and let's take a step back. I know it isn't super beautiful, but it totally works. And it's supposed to give you as a developer, you as the application manager, as the account manager, as much information as possible without being like too visually displeasing. So yeah, so first thing we can see here is the account information, including the manager and the proxy address of the account. And this is purely for reference, as well as the administrator of the account, which you can see is this multi-sig, and we can see if it's a monarchy. Down here, this just allows for manual execution on some of your modules, but we can skip that for now. So within each of your accounts, the abstract proxy contract actually provides native value calculation for your assets. And what this allows is for your account to reach out to arbitrary liquidity pools in Cosmos and calculate the value of like your account using those liquidity pools. And why is this useful? It means that in your smart contracts, you don't have to rely on any centralized APIs, and you don't even have to rely on them being listed or being like high liquidity assets and known by the community, because this, as it reaches out to these liquidity pools directly to calculate the value, it allows for long tail assets to be used in these type of applications without risk of a centralized API screwing that up with like a delayed price feed or so on and so forth. And we're also going to be supporting time-weighted average prices from any number of sources. Right now, it's only supported via osmosis, but yeah, we will be supporting that in the future. So yeah, the first thing I did here is, or the first thing you need to do once you create this account is register a base asset. And this base asset will form as, of course, the cornerstone or the base by which all of your assets in your vault are calculated. So I'll go ahead here and register. Oh yeah, Juno X. You'll notice it's kind of like a weird syntax, right? It's we prefaced every asset with the originating chain that it came from. So this, of course, is native to Juno, and we're on Juno testnet. So it's Juno X. Like it went from Juno to Juno X. If this was IBC'd from Osmosis, it would be Osmo Juno X, because it came from Osmosis, went to Juno, and now it's Juno, and the asset name is Juno X, and so on and so forth with other chains and other assets. So we'll go ahead and propose that we register the space asset. As you can see, we're executing this message on the module, on the abstract proxy module, and updating the assets and adding Juno X with the value, the price source down here is registered as none. And so, yeah, we'll go ahead and propose this, and we'll propose it and register it. This just shows the multi-sig flow. It's a little bit slower, but it's pretty cool, because this means that you can manage your account directly through a multi-sig. You could get together with your hackathon team and protect your assets in your vault, protect your modules, and yeah, it's security. So we'll go ahead and execute this since I'm the only voter, and approve it. So right now on testnet, we actually on this front end, we don't have other assets available that are registered within abstract name service, but I'll go ahead and show you that on the other front end. Now that I've demonstrated the multi-sig functionality. So I'll head over to app.abstract.money, and you'll notice that this has a little bit different naming. Everything says apps, and it's just we've flipped names here and there. So it's now account. And abstract OS is not abstract OS, it is abstract. So let's go and just create a monarchy, super easy. Monarch, Monzo. And go ahead and this is a glitch with Kepler, actually on the Terra testnet, where you always have to use the highest gas fee. So yeah, so I'll go ahead and create an account using the monarchy. And as you can see over here, we'll do the same thing. We're registering Terra 2 Luna, because it came from Terra 2, and it is Luna. And oh, I guess what I could show you before going to register additional assets is the abstract name service portal, which is down here. When it loads, when it doesn't load, yep, we'll go to the abstract name service portal, and there we go, and we'll pop that over to the side. So these are all the assets that are registered on Terra 2 testnet, and these assets are actually scraped from the dexes, and they're using the Astroport's parrot factory. We can actually figure out all of the assets that should be within Terra, and we compare these against the chain registry so that we make sure that the developer has the most accurate assets and the users have the most accurate assets possible. In the future, this will be managed by DAO, but right now it's just managed by Abstract. And as you can see down here, we have Terra 2 Luna, and it resolves to ULuna. If we want to look for Astro, of course, it resolves to the CW20 address for Astro. So let's go ahead and register. Let's go see, and yeah, let's register Astro. So we'll click enabled, and we'll choose the value pool and the value derivation for Astroport. And so since we have Luna already as a base asset, we want to choose a pair that has Luna available, and that of course would be the first one. And you may be wondering, like, well, what if I want to calculate it through the RAND Terra 2 pool? That's totally fine. but you have to make sure that there is a path. You can imagine it like a directed graph, like a path from Luna to Rand, and then Rand to Astral. So let's go ahead and enable, Kepler hates me, enable Terra to Astral. And so we'll register this on our proxy. And now our vault will have both Astroport and Luna both enabled. Cool. So why don't we go ahead and deposit some funds into our account? So 0.5 Luna. And hi. And while this is going on, we can actually scroll down the Abstract Name Service Explorer, and I don't have the DEX pools listed here on the Name Service Explorer, but shortly I can show you the DEX pools registered within Abstract directly from the smart contracts through our API for things that may not be available in the front end. All right, so now we have 0.5 Luna, and the value is of course 0.5 Luna because that's the only thing in their vault. So why don't we go ahead and enable the DEX module. So this DEX module, as Howard mentioned, it acts as a decentralized API that interfaces with every DEX within Cosmos, will interface with every DEX within Cosmos through a standard interface. So we'll go ahead and enable this DEX module. Kepler. We'll go ahead and enable the DEX module. Kepler likes to stay open sometimes and reject all my transactions. So that is what is happening now. Kepler. Sorry about this. Okay, we'll try signing out and signing back in. This is an issue with the browser that I'm currently using, so I do apologize for that. If this doesn't work, then I'll go ahead and switch to Brave. Yeah, okay, we're going to switch to Brave. Are there any questions so far, by the way? No?
When Terra Station support.
When Terra Station support, so actually the Celatone team they're working on like a really cool, I'll show you later. They're working on this really cool explorer for Osmosis and Terra and all of the Cosmos chains. They're actually working along with TFO to build out Terra Station support for Cosmos Kit, and there's an open PR, but it's waiting on Terra. Imagine that. Extension context invalidated. That's incredible. I love technology. All right. I'm going to drop the call, restart my browser, and then be right back. So, Howard, you want to take it for a minute?
Sure. Maybe I'll just give some more background on why we made this like ANS, this abstract name service. So one of the kind of big issues with IBC is that when you want to, for example, send a token on a different chain and transfer it to some different account on a different chain, or even interact with contracts on a different chain, you need the address of that token or the denomination of that token when you send your message over to that chain. So that means that in a hub architecture, or really in any IBC architecture, if you want to interact with the other chain, you need all the addresses that are going to be relevant to you on your local chain in order to put them into your message and send them over to the other chain. So instead of doing that, again, we use this human identifier, and we just pass it in the IBC message, and then on the chain where it arrives, it can resolve what the actual denomination of that asset or that contract is, so that there's no need to store this asset information and these denominations all over the place when it's not really required. So yeah, that's why we did that. Besides, yeah, another thing that we didn't really mention is that we have a tool called Boot to script our smart contracts. So you can imagine that if you're building this module and you want to test the functionality of it, that you need to basically instantiate a whole of abstract in your integration tests or on your local daemon before you can start testing your own functionality. And so we created this tool called Boot, where you can specify interfaces for your smart contract. You can add the WASM files and the endpoints of the contract to like a virtual contract. And then you can share that with anyone who is trying to build on abstract, so that they can easily deploy the whole application on their mock environment and get started with like one line of code. So that's something that we're also pretty proud of.
And also, it means that every team that uses Boot and that exposes the Boot structs in their package. So like 42 built an auto compounder, and they built a Boot struct, and they of course passed in all of the instantiate messages for this. It means that teams can collaborate with one another in testing and writing testing infrastructure and being a lot more interoperable in the Cosmos. And some more alpha, IBC will be enabled in Boot within the next few months, or within the next month, hopefully, which will allow you to test multi-chain deployments really easily through your Rust integration testing, and deploy your contracts on every chain imaginable. It takes us about 2 minutes to deploy all of abstract. And that 2 minutes is just because of the block speed for the given chain, of course. So if we deploying on injective, maybe takes like 30 seconds. It's kind of cool. So now that the browser is being nice to me, we can see I clicked the Dex enable, and we can see install module. We have the instantiate message for the module, which is actually blank, despite what the blank base64 says, because it's an API. Because the APIs are shared within all accounts. So Dex by abstract with the latest version will approve this. And we have insufficient fees because of Terra. And we'll just execute it with high fees. And once this is enabled, we'll actually be able to swap on the DEXs that are enabled on Terra testnet right now, which is actually just asked for it on Terra testnet. So within the module execution page, or the details page, we can actually see the interactions that we can do with this module. And this form, this is not generated, or this is not written by me. Well, I did not like manually create this form with the fields. This is actually auto-generated from the JSON schema of your contracts. So any abstract module is able to be executed and queried, or any contract for that matter is able to be used via form using the JSON schema, and it makes it a lot easier as a developer to interact with your contracts. So here, I'm going to manually execute a swap as opposed to through the interface that I've created with this swap over here. And so I'll ask for Terra 2 Astro. I would like to receive some Astro. I can say that I don't care about the price. I don't care about the spread. And yeah, maybe I want 1,000 micro Astro. There's a weird re-render. And so this name here is the name of the offering asset, which is Terra 2 Luna, and I'll swap on Astroport. And down here, there's a toggle where you can execute this transaction as the account. So using the funds in the account, which of course are over here, we have 0.5 Luna in here, and so I'm executing as the account as opposed to as the user. So let's go ahead and execute this. And once this goes through, we can actually see the transaction. And once the logs are here, we can see that this reached out to Astroport on the appropriate pool. It resolved all of this in the background. We can ignore that. Okay, this is a lot of garbage. It resolved this all in the background through abstract name service to make it really easy for developers to do swaps. So the name service, you can actually ask for the Astro and Luna pool on Astroport, and it resolves the contract in the background. So now that this has executed, we can refresh our account. And as you can see, we have our balance of Astro, and which is like 2 and a little bit less Luna. So I guess I could have done a bigger swap amount, but yeah, it works for swapping assets in your vault. We've also exposed this as a custom interface over here. This will allow you to select any DEX across the Cosmos and select your offer and your ask assets and swap it, of course. So something else that each of the APIs has as a core functionality is the ability to add additional authorized users to your API allow list. So we call these traders within abstract. And so these traders, of course, I am a trader by default because I am the admin of the account. But if I disconnect and I switch wallets to a different account, connect, and attempt to make a swap on here, it's going to tell me that I am unauthorized because I am not an admin. So what I can do to alleviate this is actually go and switch accounts again to the abstract account and add this other account as a trader to this API. And this trader on the API is registered specifically for your account, and you can allow others to manage it because a team may make a module like let's say the DEX module, and you want to allow other individuals to make a trade on expected Terra got Juno. Oh, that makes sense. Yeah, it allows you to authorize other people to perform actions on your account. And we'll switch to Terra. I wish there was a search here. Terra 2 testnet. Am I on the correct account? No. Cool. Abstract test. We'll add a trader. Adding this secondary test account as a trader, which will allow the secondary account to execute transactions. I really wish you, if any one of you want to do a cool hackathon project, if you make it easier to switch accounts in Kepler or any wallet for that matter, that would be awesome. Yeah, so connect. And now, theoretically, I should be able to make this swap. Theoretically, I should be able to execute this swap. Maybe in this non-pretty UI. No, execute as user.
You're actually, yeah.
Yeah, there we go. So I can actually execute this swap as a user. I'm using my personal Luna in my account to swap for Astroport. And
It's still using the Luna in the account, but now your address is allowed to execute the transaction, right? And so, yeah, this is like more important for modules that take on dependencies. So you might want to add a contract to your like a module to your account and to your application, but you don't want it necessarily to be able to execute arbitrary transactions. So you can add it as this trader to this DEX API, and then it is allowed to perform trades, but nothing else.
Yes. Yes, absolutely. And we can actually see that in a second. Let's enable the CW let's enable the CW staking module with the correct account. And after that we'll enable an application which depends on both the CW staking and the DEX API. And it will give us an authorization error telling us that when we do an action through the autocompounder that it is not authorized on one of the APIs. And this is, of course, a security feature. Everything should be off by default, and as the user, you should be able to authorize additional permissions and additional permissions for your modules to additional modules for your other modules to access. So yes, let's go ahead and install the autocompounder module. Okay, I will admit this interaction is not working right now, so I will not be doing that, but I will instead highlight an account with an autocompounder already installed, and show you that this address, which ends in ZFQ, the autocompounder is authorized on the CW staking module, ZFQ, as well as the DEX module. So no module should be allowed to have more permissions than are authorized as user. So yes, okay, cool. I think this is about it with the actual account management within our front end. There are a few more things that you can do. However, yeah, they're kind of gated behind the modules being deployed to abstract right now, which some of them are not on testnet. So I'll go ahead and show you the module registry. We'll pop out this tab. And so this is where each of the modules are listed to the registry. And developers can choose to add installation fees or subscription fees to their modules coming soon, TM. And so yeah, so you can see all the modules registered with an abstract. As you can also see, we have each of the CW Plus contracts registered, which means that your account can basically use these quite easily through the UI, should you please. What else we have here? We have some additional developer tooling. This is quite basic tooling. It's somewhat like CosmWasm tools, where you can select any network, like no matter like what network you're you're connected to, you can select any network that supports CosmWasm and execute messages there. So for instance, here I'm connected to Juno testnet or Terra 2 testnet, so on and so forth. You can instantiate contracts, query, execute, migrate, upload contracts. Yeah. And I guess the final tool that I want to show you in the abstract front end is for